Okay, so let's have a look at this. Okay, so first things first, we need to find that base angle. Nice and easy, just stick it in your calculator, or you might know. Okay, so you simply do it just by taking the cos inverse of root 2 over 2. So you're happy it's 45 degrees? Yeah, so that's a base angle. Base angle, remember, is the angle which is closest to 0. The angle which you get by thinking about the right angle triangle. Okay. All right, fine. So we've got x equals 45 degrees. Next thing we need to do is draw the graph. So we can find all of the angles between 0 and 360. So all right then, let's draw our cos graph. Remind me, where does the cos graph start from?
1.
Good, so we get this idea. Okay. Okay, cool. And then every 90 degrees, something interesting happens. That's 1. That's -1, so 0. That's interesting. That's interesting. That's interesting. And that's interesting as well. Okay. Good. All right. So we need to find all of the angles on here which have a height on the graph of root 2 over 2. Well, root 2 over 2 is kind of sort of about there, I guess. Okay, it's a little bit over a half. You can always stick it in your calculator to work out what the decimal is. It's like 0.6, I guess. No, 0.7. Yeah, 0.7. Okay, so it's about there. So that's root 2 over 2. So just move our line across, and we just find all the points which intersect that line. Okay, so there's one over here, dot, 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 and there's one over here. Okay, dot, 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 dot. Okay, not a brilliant graph, but it doesn't matter. Doesn't matter. Okay, so what's this point here? 45. Yeah, not a great graph at all, but it doesn't matter. Okay, 45. What's this point over here then?
45 plus 3 is 270.
Yeah, perfect. So you can think about it as 315 degrees. Perfect. And in case you didn't catch that, it's just simply, you know, the distance between there and there is 45, or distance between there and there is 45, which means distance between there and there is 45, and distance between there and there is also 45. Okay? Good. So therefore, if you want to find all the angles which have that height between that domain, you get 45 degrees or 315 degrees. Does that make sense? Okay, no drama. Good. All right. Okay. Let's switch this one up slightly. So let's try solving sine of x equals root 3 over 2 for negative 2 pi less than or equal to x less than or equal to pi. Okay, try and solve this one for me. So have a look. The domain now is no longer in degrees, it's in terms of radians. That's okay though, because you can always make the conversion now, solve the question in terms of degrees, end up with your final answer in degrees, then just remember to convert it at the end. Yeah? But yeah, have a go at that for 5 minutes. Okay, can we have a look at this one? So this one's slightly different. If you're still working through that, that's fine. But let's just make sure we're all happy with this one. Okay. So how I would solve this question is by thinking about this in terms of degrees. It is possible to do it in radians if you're really comfortable with drawing the graphs and converting between radians and degrees. Okay. But if you're really not sure, just think of them in terms of degrees, then convert them to radians back later. Okay, so that's what I'm going to do. All right, so negative 2 pi to pi. What's negative 2 pi in degrees? Good, because 2 pi is 360, so negative 2 pi is going to be negative 360. Good. What about pi?
180.
Perfect. Okay, 180 degrees. Okay. So in other words, it doesn't affect anything at the moment, but when I come to draw my graph, I'm going to have to think about this domain. Okay? So when it's in terms of x, when it's in terms of the thing which I'm trying to solve, it's called domain. If it's in terms of the y values, it's called the range. Okay? But just think of it as like a range. Okay? Okay, so first things first, I need to find my base angle. I can do that by taking the sine inverse of root 3 over 2. Okay? Or you might know it. Does anybody know it? Was it? 60 degrees. Perfect. Okay. Good. So that's my base angle. So now it comes to drawing the graph. I just need to be careful because I need to make sure I capture all of that domain. Okay. So I'm just going to draw a nice long line in. Okay. Because I'm going to go negative as well, I'm going to stick my y-axis somewhere in the middle. So somewhere about there. All right? Okay, so this is going to be x. This is going to be sine of x. Here we go. Right? So I need to draw everything from negative 360 to 180. Okay? During the bit from 0 to 180 is easy. Just remind me, where does the sine graph start?
0.
0, perfect. So I need to start it at 0, okay, and I'm just going to draw one full cycle like that. Okay, that's enough for me at the moment. Okay, so that's going to be 90, that's going to be 180, and in fact anything after that I don't care about because I only want it to draw it up to 180 degrees. So actually I can get rid of all of this. So if you've got a pencil in the exam or something, that would be really good, okay, because then you can rub that off. Okay, so this is the bit from 0 to 180, but if I want the bit going back to 360, I've got to go back the other way. In other words, I've got to have a repeat of that graph over here. Okay, so just think I'm going back the other way around the circle. I'm going clockwise. Okay, so in other words, I'm going to go down, then up, and then back down again. Okay, so it's not a brilliant graph, but it will do. Okay, remember every 90 degrees something interesting happens. So you're happy this is the next interesting point. I've got to go back by 90 degrees. So what's this value here? Negative 90. Good. Go back again another 90 degrees. Negative 180. What's this point here? Negative 270, and then finally negative 360. So you're happy now I've got the domain of the graph correct. Got it between negative 360 and 180. All good? All right, fine. Now it's just a case of solving exactly the same thing as I had before. All right, same thing as I had before. All right then, root 3 over 2. Root 3 over 2. It's about, what, 0.8, 0.9? Something like that? Okay, so therefore I'm going to draw my point up here. So I'm going to say that's root 3 over 2. Remember, it doesn't matter like where, as long as you get it roughly correct. Okay. Now I'm going to draw my line across for all of the graph, so including everything on the left as well. So for my entire domain, I'm going to draw my line across. Okay, and then I just find all the intersection points. So look, there's an intersection point there. 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 Does that make sense? So I've now got 4 intersection points. 4 intersection points. Just because I've got a different domain that I'm working between. Okay? Now I already know one of these angles. I already know 60 degrees. Where's 60 degrees going to be? This one here? Yep. And then from that I can work out everything else I need. So the distance between where it crosses the curve, or crosses the axis and that point there is 60. Or from where it reaches a peak to that point there is 30. Okay? So therefore, what's this point going to be? 120, perfect. Either 30 degrees on or 60 degrees back from 180. Okay? So that's 120. Okay? Then I just need to think, what's this point here?
60 plus negative 180. So it's 240.
Negative 240. Good, exactly. Because you're just thinking it's 60 degrees further back. Like distance from there to there is 60. Distance from there to there has also got to be 60. Okay? It's negative 240. What's this point going to be?
Negative 200.
Perfect. Okay? So those are my solutions. Okay? I've got x equals, let's do it from left to right, negative 300 degrees, negative 240 degrees, 60 degrees, or 120 degrees. That's it. I'm done. Aren't I? Good. You remember where I started, okay? The original question specified it had to be in terms of radians. So the original question specified it had to be in terms of radians. And you knew that because it was given in terms of pi. I chose to convert it to degrees because it was easier to solve, it was easier to work with. I didn't have to do anything differently, which means that my final answer I need to convert back into radians. Otherwise I lose that mark, okay? So, all right then, how do I convert from degrees into radians? Remind me. Absolutely right. So I multiply by pi over 180 degrees. Okay. So here we go. Here we go. I just need to multiply all of these by pi by 180. I can try and do it in my head if you want to, but if you've got a calculator.
First one is negative 5 over 3 pi.
Negative 5 over 3 pi. Cool. Next one. Negative 4 over 3 pi. Cool. Next one. Pi over 3?
Yeah.
What's the last one? It's going to be 2 pi over 3, isn't it? So just double that.
Yes.
Cool.
Yeah.
Excellent. That would be my final answer. Okay, so just make sure you definitely convert it back into radians at the end. All good?